Hi, hello everyone. We're glad to see all of you on our educational event today. It's a pleasure to be here. And thank you, especially for those who are connecting from Portugal during national holiday. I believe that means that you're twice as interested in improving your skills. And thank you very much for coming. Yes, and just a couple of words about our event today. So overall, Tech Talk is a DevExperts community that organizes various meetups, both in online and offline mode, where we discuss new tool methodologies, talk about our tech stack, and share our know-how with the professional audience. We are the DevExperts team, the team of DevExperts company. We have been working for nearly 2 decades consulting and developing for the financial industry. We make such products as trading platforms for brokers and investment firms, market data management systems, matching engines for exchanges, and etc. etc. Our R&D and support centers are located in Europe, Asia, and North America. So we are quite distributed team. And today we are going to talk about quality assurance. And let me name our event today QA Ops Day. Our event is dedicated to QA automation and operations, and I'm happy to introduce our speakers. So they are Kirill Kozlov, software engineer at DevExperts, and Dmitry Gorbunov, QA automation team leader. Dear guests, please use chat and the Q&A section. Our speakers will answer all your questions right after the presentation or a bit later. So please don't be shy and ask everything you want to know. So right now I am ready to start and to give a microphone to Kirill Kozlov. Kirill is going to talk about parallel execution of desktop tests, the idea that can speed up this testing process. And yes, please, Kirill, the stage is yours. Good luck.
Now, let me share the screen. Yeah, can we see that? I guess we can.
Not yet.
Oh, my bad. Oh.
Yes.
Now it works. Hello, my name is Kirill Kozlov. Today I'll talk about our experience in parallelizing desktop autotests and applying different approaches to parallelization. And before I start, a few words about me. I'm an automation engineer from DevExperts. I've been engaged for 1.5 years in web and mobile test automation, and for 2 years I've been engaged in the automation of desktop tests in DevExperts. So what will be discussed? In the process of interacting with the application, we control various elements of the application using mouse, keyboard, and other devices. Below a tab we want to test, then we click some buttons, then we compare received states with the expected ones, and we save report. It's pretty simple, I guess. Suppose we have automated the described actions. And now we suddenly needed to make them work in parallel for some reason. For example, to increase the speed of work. In web or mobile tests, this is easy to do with existing frameworks. For example, in web tests, additional instances of browsers are created. In mobile, additional instances of emulators are created too, and tests start to run in parallel. On a desktop, you could do the same, but there are some limitations. I'll tell you what limitations we had, how we dealt with them, and where we came to. First, we'll talk about the types of tests and their features in fintech. I also talk about the problem of fragile data and the difficulties that we face when we parallel tests. Next, I'll talk about all sorts of tools that we considered in our stack and why the considered tools do not suit us. We also analyze our previous method of parallelization and its features, and why we wanted to change this situation, how we changed this situation, and what we came to, and what happened in the end. Now let's start with the specifics of parallel runs. Probably everyone understands that as the number of tests is increasing, so their execution time. Sequential execution is certainly good. There are fewer problems with it, but when there are several thousand of tests and you suddenly want to integrate them into CI, it becomes necessary to somehow speed up their work. Parallel launches come to our rescue. For example, we can run tests on different machines. This is what we did earlier. Distribute tests across across multiple machines, with each machine running the test sequentially. There is also another way. We can run tests in parallel on a single machine, such as mobile tests with the multiple emulators and web tests on multiple browsers. We did roll the same thing in desktop tests, but with some peculiarities in their preparation. Let's now discuss these features that we had to take into account when parallelizing and how we did it. In the process of parallelization, we take into account the area in which we write tests. For example, in fintech, there are certain difficulties when working with data. Let's look at a few examples of such data. Some of them are users, profiles, and accounts. These certain entities that have many properties. We should change them carefully, especially if we are talking about parallel runs. Changing these entities in parallel can lead to collisions. So, for example, if we use one user in parallel tests, we'll definitely run into problems. When we prepare user for the test, we cancel orders, add money, change other parameters. And if we change these parameters in one test, then the other test will not know about these changes, which can lead to unexpected results. Therefore, we came to a conclusion that we need to distribute different users for different tests. We get this distribution by blocking users in general blocking system. The next example of fragile data is instruments. These are large tables with a bunch of properties and parameters that also need to be changed with care. For example, one test can change trading price of an instrument, another limit or expand trading at certain hours for this instrument, or ban trades altogether. Soon this use of instruments will create chaos and uncertainty in tests, and it can be difficult to understand why a particular test fails. Therefore, just like with the users, we block the instrument for each test and remove it at the end of the test. Another example of specific restrictions is global settings. They can affect all tests in parallel. For example, if we have tests that change the global trading schedule, and we must take these settings into account when running them in parallel. These examples are just the tip of the iceberg of all the features of fragile data in fintech. And I hope these examples described a little idea of what we have to work with. Another example of our limitations is that we have a lot of tests and we need to form a set for testing. It is possible to create a static test suite and modify it manually, but this is too expensive for us. Therefore, we form the next set of tests dynamically. And how we do this? For this, we use the risk-based approach. We have a bunch of tests in Jira that can have different properties and can be selected by different fields. Using Jira query language scripts, we select a list of tests according to certain criteria and form a set of tests to run. Now we have discussed several features which imposes restrictions on our parallel runs. The first are users, portfolios, and accounts. Next is instruments, global settings, a dynamic test suite using a risk-based approach. And let's now talk about the existing tools, the technology stack we use, and why we didn't use these tools for our task. We automate tests in Java using Cucumber API and JUnit. And TeamCity acts as a CI. Why don't other tools suit us? As you know, during testing, we need to click on the buttons, check the receipt states. As a result, certain limitations appear in the parallelization of tests on a desktop. We also discussed the limitations of fintech data and other entities, and all this forced us to invent our own tool instead of the existing ones. For example, the same Cucumber can parallel tests out of the box, but due to the above-mentioned limitations, it does not suit us. And let's now discuss the limitations we have in more detail. You may have come across a similar feature, one application per one video buffer. We cannot run several applications in parallel and try to interact with them at the same time. We have one cursor or a video buffer. For example, by clicking on a button on one application, we'll not be able to click on a button of another application at the same time because we have one cursor. We also have a limitation of the framework itself to launch an application in JVM. We run tests in the same place where our application is located. So one application can only be launched in one JVM due to JVM restrictions. Another limitation is the specific division of test cases into groups. According to certain criteria or tags of Cucumber features, we collect test scenarios into groups, and groups are executed in parallel. And tests in the group itself are executed sequentially. Well, let's now discuss how we run tests in previous version of framework. And in the first step, we dynamically fetched tests from Jira to run. We then split the tests into groups using Cucumber text and Java code. Then we formed runs from these groups on TeamCity, assigning a machine to launch and placing them in the queue for execution. At this point, we used the TeamCity API to manage the queue and get information about free machines. At the next step, groups of tests were executed in parallel on machines, and in one group, on one machine, they executed sequentially. Then we collected reports for each group, logs and screenshots and other files, and formed a final report from them and uploaded them to TeamCity. This is what the process of running tests looked like earlier. As always, such launches have their own characteristics, and let's discuss these characteristics in more detail. The first feature is productivity and the speed of work. One machine runs one group of tests sequentially, so we do not need to worry about the machine's performance causing the test to fail. Therefore, we do not worry about the load on the CPU and RAM. Due to the massiveness of the configuration, it was necessary to constantly monitor the work of many components necessary for the successful execution of tests. We might not notice that one of the machines was out of order, as the percentage of failed tests could be small. The malfunction of one machine could be unnoticed for a long time, which could affect subsequent runs. With this test execution process, it's difficult for us to understand when to collect log files. Since TeamCity does not have a ready-made API for interacting with logs, we had to write our own API for collecting logs and reports and other files. The machine are powerful enough so that tests performed sequentially on one machine do not take even 10% of the machine's performance. This situation has its advantages since we do not care about system performance, but it's not a rational use of resources. That is, we would like to use the power of the machines in full. Another feature, we are one group of tests. We have one group of 8 machines, and the run of one group of tests completely occupied the entire group of machines. To run another group of tests, you'll have to wait until the machines are free. And now let's talk about why did we want to change the executions method. The previous method of running tests had its pros and cons, and we thought that the cons were in the majority. Therefore, we looked at the features of the new execution method. We decided to consider running the tests in parallel on the same machine with multiple virtual displays. With this execution method, the display has its own video buffer. In other words, it has one cursor. This method solves the problem of launching multiple applications. on one machine. One virtual display runs one application. Empirically, we set the maximum number of stable running tests on different displays and achieved the maximum resource utilization on one machine. We were able to run up to 15 video buffers on one machine. The tests on these displays run smoothly, and the success rate was comparable to that on the previous run method. With this approach, all log files, reports, screenshots are in one place, and we know exactly when we need to collect them and draw up a final report. The problem of limiting one group of machines was also solved. This launch takes only one machine. Therefore, we do not need to wait until the entire group of machines is free. Now let's talk about how we implemented this approach and what changes we introduced. We have created several video virtual displays on Linux machines, as I said before, and there are 15 such displays in total. We have changed the process of adding tests to the queue and executing them. Now we create and control the queue exclusively using Java. We determine on the spot a free display for the next run. In this approach, we completely decoupled from using the TeamCity API to run tests and manage the queue. And we replaced it with our own API written on Java. All control modules are in one place and on one machine. And what have we achieved, and what are the advantages of this method? The main advantage is that it greatly simplifies the support of the test runner. We got rid of a lot of intermediate modules involved in the test run process. These modules required configuration and constant monitoring of their performance. We got rid of the rigid binding to a specific CI tool. And now we do not need to rewrite the logic, and we can quickly switch to another CI tool if the need to be. The efficiency of test execution has also increased. By running 15 tests on one machine, we make the most of its resources. And at the same time, the rest of the machines remained free. So, well, we've spoken about two approaches to parallelizing autotests, considering industry and technical constraints and our experience in implementing these approaches. Thank you for your attention, and I'm ready for your questions.
Okay, yes, guys, you can use Q&A section, and you can use chat if you have any questions. Please don't be shy. And by the way, I see new guests. We have more people. Happy Republic Day, dear Portuguese colleagues, if you're here. And by the way, Kirill, after all, I have one question. Even I'm not a QA engineer, but tell me please, you can parallelize the test, creating your own virtual machine for each parallel run. Why is this option not suitable?
Yeah, I thank you for this question. I can answer.
Because I didn't get it, sorry.
Okay. I guess because this it's and this method causes many problems with many problems with the interaction to these virtual machines and controlling the runs. So we thought about this method, but parallelizing tests to virtual displays have more advantages. So we use the virtual displays instead of virtual machines.
Okay. And why do I have to choose test to run? So can I start all at once?
Yeah. We have about 2,000 of tests we should run, and the test suits change simultaneously from day to day, and it is extremely difficult to manually monitor these test suits. So we need we do not need to start these test suits at once. So we group them because of many limitations of fintech and our execution methods, I guess.
Okay, I see now. Well, I have no questions from my side actually, and there is no questions yet in our chats. So thank you for your presentation. No.
I see the question.
Yes. So yeah, please.
Is the display buffer parallelism technology a specific solution? Does it work for any languages or JVM based? Thank you for your question, Daniel. Display buffer parallelism technology is not a specific solution for the languages for JVM. It's a specific solution for Linux machines. You can create a virtual display on a Linux machine and can run, for example, for example, you can run just a text editor in this display. So it's not about the specific languages. It's about Linux maybe limitations. As I know, we can run virtual buffers on Linux machines, and I don't know that we can run it on Mac or Windows. So if you use Linux, you can simply add the virtual buffers and run your tests, adding the virtual display environment variable to your command line script, or maybe to your program script.
Oh, yes. Yes, thank you. Thank you, Daniel. And we have one more question. Yeah. Please take a look at Q&A chat.
Could you please repeat, how do you manage forming and ordering the queue? Isn't it about using message brokers like Kafka or RabbitMQ? No, we don't use Kafka or RabbitMQ. Because we have we have thousands of tests and we group them into hundreds of groups. So we do not need any special API to manage this queue. We just have one Java blocking queue and gets the groups from this blocking queue and run them in parallel. So we do not use any additional APIs.
Let me add a few words there. So hello, everyone. My name is Dmitry. Ivan, maybe your question was about the overall how we manage the queue. And right now, the queue of the test execution is managed by TeamCity. So TeamCity just has its own implementation of for tasks to be executed. We do our own stuff on our side. So we prepare the tests and we batch them into groups and we queue them to the TeamCity execution line, to be called. And then TeamCity handles all the distribution according to its own resources and its own configurations.
Yeah, but this is a earlier approach, earlier method that we used before virtual displays.
Okay, so can we move further? What do you think? I believe yes.